안녕하세요. 모두를 위한 데이터 인텔리전스 산업 특집 인더스트리 에디션 웨비나에 오신 것을 환영합니다. 오늘은 세 번째 세션인 미디어 통신 및 게임 산업을 위한 데이터 인텔리전스 내용으로 준비를 하였습니다. 올해 하반기 9월부터 시작된 산업특집 웨비나 시리즈를 통해 지난 데이터 AI 서밋 인더스트리 포럼에서 다루었던 주요 글로벌 고객 사례와 데이터브릭스 데이터 인텔리전스 플랫폼을 통하여 생성형 AI 도입을 위한 준비와 활용 방법에 대한 이유, 그리고 정의를 설명드리고자 합니다. 오늘 약 45분 정도 진행되는 세션에서는 먼저 첫 번째로 데이터브릭스 글로벌 GTM 통신 미디어 엔터테인먼트를 담당하는 리더이신 노아 레빈과 루빈 수타라 님께서 전달해 주시는 데이터브릭스 데이터 인텔리전스 플랫폼 전반적인 개요로 시작을 할 예정입니다. 이어서 온라인 게임사인 드래프트킹스를 통해 데이터브릭스와 함께 세우는 ML 전략, 그리고 올해 MLB 월드 시리즈에서 텍사스 레인저스 팀이 데이터브릭스를 통해서 어떻게 우승 전략을 세우게 되었는지 그 뒷얘기를 상세하게 들어보실 수 있는 시간을 준비하였습니다. 웨비나 중에 궁금하신 사항은 Q&A 창을 통해 문의 주시면 저희 데이터브릭스 팀에서 답변을 드릴 예정이며, 모든 세션이 종료된 후 설문조사에 응답해 주시는 분들 중 추첨을 통해 기프티콘을 선물해 드릴 예정입니다. 많은 참여 부탁드립니다. 감사합니다.
Hi, I'm Noah Levine, very new to Databricks. This is actually my 7th week. I'm the new communications, media, and entertainment industry go-to-market lead. Super excited to be here. Thank you for joining. Hopefully you can hear me okay. I'm like echoing in my ears. We are going to have a really amazing 2 hours together. The zeitgeist that we're all hearing all the time is all about generative AI. And we're going to be talking about today what the promise of generative AI can bring to the table for all of us and all of the industry in whatever vertical we're in, as well as our organization. The thing about generative AI is that it's only as good as the data that you feed into it. And that is a big challenge, and it requires a new type of foundation to be able to store, organize, and extract all the value that you possibly can out of your data. And the good news is you're in the right place. That foundation is provided by Databricks. The Databricks Data Intelligence Platform is actually the same set of products and functionality that you're probably all intimately familiar with. And Databricks Data Intelligence Platform provides those capabilities to be that foundation. It's not only about generative AI, it's about the components that go into your data estate, how you manage identity, how you keep track of your customer interactions, and then the purchases and the transactions, your networks, the devices that you have. And when you think about the way that we all organize our information to be able to execute, generative AI really sits on top of it all. And it supports a virtually infinite number of use cases, ranging in a scale of complexity from super simple to relatively complex. And there's really 3 or 4 categories. You have your training wheels, where most organizations are. Then you move into eliminating inefficiencies, cost savings. A big, huge part of that is workflow automation. And then we move into streamlining business processes, which could be things ranging from you're generating content and you want to use a large language model to assist with the process of expediting the generation of that content, to complex fraud detection, prediction, compliance, et cetera. And then generative AI even provides the ability to generate new revenue, new lines of business. So over the next 2 hours, we have a really fantastic collection of people that are going to walk us through not only generative AI, but the building blocks that need to be in place to be able to support this grand new vision, this future. We're going to start off with risk versus innovation from Robin Sutara, who's our field chief data officer at Databricks. Then we're going to move into an executive panel with a number of illustrious, great companies that you'll meet all those people shortly. And then we're going to have 4 presentations. One from DraftKings, SciPlay, the Texas Rangers, and finally 7 West Media from Australia. So without further ado, I want to introduce Robin Sutara, our field chief data officer. Thank you. Here's the clicker.
Thank you.
Thank you so much, Noah. So as Noah shared, I am a field CDO with Databricks. I am one of 4 that cover the entire world. And so I have the distinct benefit and pleasure of getting to meet with lots of our most strategic customers to talk to them about, I know you'll all find this a surprise, about generative AI as of lately. Most of these conversations actually that I have are with the CEO and the board because they're all trying to figure out what is this hype around generative AI? What do we keep hearing about it? So I was hoping to kick off your session today to share a little bit with you on what are some of the questions that I'm receiving from the board? How are we thinking about it? How are we positioning it? And then hopefully you'll hear some great examples of some organizations that have done this and where they are on the journey. So I'm hopeful this will get you a little bit of context. So typically what you hear from the board are 3 questions. They sort of ask us, where's the market going? How do they think about Gen AI? Where are my competitors when it comes to generative AI? And where are we in comparison to our competitors, right? They all want to know who's doing something that I'm not, right? Who's further along than I am? And so we're really trying to think about looking at these questions. The problem is that's not really what they're asking. What they are asking is, we know we need to get on the generative AI bandwagon, but we need to manage the pace of innovation that generative AI represents and the risk that it represents to our organization. How do we make sure that we're protecting ourselves and our organization and our data and our IP and our trade secrets and all of those things, because all of that represents a potential risk domain area that organizations have not had to think about in the past. So the things that I talk to them are, okay, if we think about risk versus innovation, what are the factors that we need to consider? Do you have a culture of innovation within your organization? I should probably give a little bit of context. I've been with Databricks a little longer than Noah, 2 years. And prior to Databricks, I spent 23 years with Microsoft. And the last half of my career at Microsoft, I was chief data officer of Microsoft UK. So all I focused on actually was, how do I propagate a culture of innovation leveraging data? It was all about the people. It was all about the process. It was all about change management. And so a lot of organizations are struggling now with generative AI because what does that mean if you're going to bring generative AI into the organization to innovate, to create new products and services for your customers, for your organization, drive optimization of operations? How do you create a culture that allows you to be agile in that approach? Do you have the right foundations in place? You'll hear a lot about the data foundations, the platform foundations that you need to be able to do that. And then how do you prepare for future risk? And we'll talk a little bit about that. So let's talk about an innovation culture. This is really people and process. I think, who remembers the ChatGPT first became public? We saw Samsung, 2 poor little employees, put some trade secrets in there because they thought they were doing the right thing for the company. And then all of a sudden, they lost the intellectual property right to the trade secrets that they put in there. I happened to live in London at the time. Immediately, several European countries said, nobody touch ChatGPT in the organization, all right? Nobody can use it in the entire country. Does everybody remember this story? Yes? So really, the interesting part with that case is not that the employees were trying to do something negative for the company. They thought that they were innovating, but they didn't have the right boundaries in place on how can you use ChatGPT? It was interesting. When ChatGPT was first released, I got a call from my grandmother. Like, I'm hearing all about this great thing called ChatGPT. How do I use it? Interesting now is, guess what? If you're using ChatGPT and my grandmother's using ChatGPT, you both have the same competitive advantage, yes? But you have to think about what are the secrets, what is the data, what is the insights that you have that nobody else has. That's what makes it valuable. And so how do you create the right agile capabilities across your organization that allow people to use generative AI and the technology to innovate, and they know what policies and procedures they have to follow without it being a complete stoppage of innovation? How about the Air Canada case? Does everybody recall this one? So essentially, a customer used a chatbot online to try to get a reimbursement for a bereavement flight. The chatbot hallucinated the policy based on the foundational data that existed and said, you can fly and we'll reimburse you later. Air Canada essentially said, no, we don't want to reimburse you later. You have to claim for reimbursement before that happens. And they essentially tried to say that the chatbot was sentient and that they shouldn't be held liable or culpable, right? So what kind of risk does that now represent? We're going to say, no, we want to innovate with AI, yet you have organizations saying we have no culpability for what the AI that we're providing to our customers provides. So lots of organizations now start to look at this and say, what customer-facing risk or mitigation of risk should we present as we think about these solutions that we're putting out across the ecosystem? And McKinsey essentially says that every organization who's thinking about innovation has got to capture generative AI. The problem is people are still trying to figure out what does that mean. And a lot of that comes down to how do you set up the right controls and policies and enablement of your people to know how they're using generative AI in a way that's within the boundaries that you want to provide for the organization. The other thing we talk about is a solid foundation. You're going to hear so much about this week that you're going to be just amazed, I'm sure. But the thing that you think about when you consider platform is that the pace of innovation in generative AI, I think, is unprecedented. How many of you watched the Hugging Face top 10 for the few weeks around March, April, May? I think that list changed on an hourly basis. I definitely couldn't keep up with it. We came out with DBRX. Within a week, there was already a new model, right, that was outperforming it. That pace of innovation is faster than anything we've seen in quite a while in the technology space, and I don't see that pace slowing down for most organizations. So if you think about that, how do you make sure that your platform is open? How do you make sure that you're not having to re-platform as the generative AI technology continues to evolve and get better and get faster? You want to make sure that across your organization, the platform is going to support the generative AI maturity that your organization is going on. You will start with prompt engineering. You will get it. Most of you are probably in RAG at this point, yes? Hands? Who's leveraging some RAG use cases in their org? Perfect. How many of you are doing fine tuning? Huh? And then how about pre-training? Nice. Super. So you can definitely see it's getting more complex. The more your organization is leveraging the technology, you don't want to have to recreate new platforms as they're leveraging generative AI. So how do you think about creating a foundational open platform that allows you to evolve with generative AI? And then the last part, the scary part, I think, is governance, right? So there's this little thing called the EU AI Act that has been enacted. Nobody knows quite how it will be enforced, but it's been passed. We have the executive order here in the US, which has also been signed but isn't actual federal legislation. In the US, you have the disadvantage that because there is no federal legislation, states are passing AI legislation, which means anywhere you do business in that state in the US, you have to make sure that you're complying with that AI legislation. The good part is most of the legislation is still very non-specific on what enforcement that means, right? But you do have to think about things like transparency, explainability, all of those things. So making sure that your foundation can support you as governance continues to evolve in AI is absolutely something that the boards of every company are starting to think about. So with that, I'm super excited to pass it on so that the team can start to share with you some very specific examples of how they are leveraging generative AI across their environment. But hopefully this was a good foundation so that you sort of know what are some of the biggest organizations across the world thinking about when it comes to generative AI. So thank you.
Using a metaphor of coaching football and how I use that to help my team adopt Databricks to build for scale. So to give you a little bit of premise, if you guys aren't familiar with football, like one of the key things is strategy. So people, you can have 100 plays, you can have 60 plays, you can have 5 plays. Like really it's how do you have a strategy in place that allows you to respond to what your opponent's doing in an effort to score points or to not let them score points. Data science is kind of the same thing. And I realize it's like a loose linkage, but bear with me. So the reality is like the landscape of technology and the landscape of problems that we're solving is evolving incredibly fast. Like the fact that we just talked about Gen AI for an hour, and a year and a half ago, nobody even knew what it was. Just like we have to be able to respond to that. And so one of the things we've been trying to do at DraftKings is how do we set our team up to be able to respond to that and take advantage of those opportunities. So to give you a little bit of backstory, so when I started DraftKings 6 years ago, we were about 400 people. We were fully in startup mode. We were just trying to survive until the next round of funding. And since then, we've obviously gone public and we're in scaling mode. But when I started, the way data science worked, it was all of the classic things, right? Like I build a model on my local laptop. I figure out how to copy and paste files onto a server. I copy SQL code from repo to repo. Lots of duplication, lots of non-repeatability, lots of non-scalability, because you're really just trying to scrap together solutions that are going to help you survive until tomorrow. As we've grown up and we've become more mature as a business, we've really wanted to settle up and figure out how do we actually scale. So, as we chose Databricks, we really settled on there's like 2 things that we wanted to get out of a platform. So the first thing is we wanted to build a flexible strategic foundation. And so a lot of like football, and my experience here is like having a great playbook allows you to respond and be very, very flexible to the competition. We wanted a platform that gave us that same kind of configurability in the data science space, right? We didn't want to be locked into like, this is how you do it, this is how you have to do it, and you have a square peg and you have to fit it in every round hole. Databricks actually gives us that good opportunity because of the way you can compose the various features and the way we can onboard. The other side that we wanted to solve was how do we maximize our talent potential? So like I said, we started at 400, we're at 4,000 now. We have a ton of people across data science, business analytics, data engineering, sports intelligence, a ton of people who are interested in playing with data and trying to help our customers with better data-driven decisions. The problem is when you have fractured processes, you have an immature processes, like it's hard to empower everybody to do well. And so as we were thinking about what platform do we want to choose, how do we maximize the potential of our talent is a huge deal for us. So this kind of lands on like, metaphorically, we chose Databricks as our playbook. So Databricks gives us that strong, flexible foundation. It allows us to respond to our competition. It has incoming functionality. The beauty is like there's things that I don't even know about that are coming out, I'm sure this week, that we're gonna be able to take advantage of and allow us to respond to different opportunities in the marketplace. The other side of it is like it's also fairly easy to use once you get it set up and configured for the end user, right? We can set up our analysts to go through and play with Databricks notebooks, and we can set up our data scientists to go through and deploy jobs through a common CI/CD process. We've been able to get all of these things up and going. So that was why we chose Databricks. Now I'm going to talk about a little bit about how we got up and going, because it was not an easy process for us to really like get going. There was a lot of let's call it process scar tissue in our teams. We had built up our muscles in playing the game one way, and now we needed to teach the team to play the game in a different, more scalable way. So the first thing we did was, at the leadership level, we really talked about like, what is our strategy and what do we want to do with data science? And it really came down to us of like, we need a flexible playbook. We also need to maximize our talent mobility, but like the actual why, like what are the business outcomes we want to get? And it was, we want to get more models into production faster. Right? I don't want to have to hire an army of people to deploy 100 models in a month. I want to be able to have one person who has the capability to deploy 100 models in a month. It's a much more efficient process. We took a look at our current state, we saw all of the different issues, and we started systematically kind of identifying where are the biggest pain points and how do we get buy-in and go along the way. And then we just adopted a better playbook. It sounds very simple, right? It's not quite so simple. So the very first thing we did was we really wanted to get a quick win. So I can give you a story from when I was coaching. I, shockingly, was not a good athlete, but I actually understood football. And so getting credibility with people who were Division I athletes was a really hard thing to do. But I learned the very first thing you do is you help them get a quick win. You understand what their goals are, what their pain points are, and you teach them how to fix something that's wrong with them. We did the exact same thing with their data science team. They're skeptical about Databricks. I could go to talk to anybody, and Robin and Barney back there can say the same thing. Like, a lot of people know how to spin up a Jupyter notebook on their local machine. I can do that. Why would I need Databricks? Why would I need to do all this stuff? So we really tried to zoom in on the problem that was the biggest pain point for us, which was collaboration. Jupyter notebooks are not the easiest thing to get feedback on. They're incredibly impossible to diff and do git commits and actual code review. And that was a pain point for us, to the point where our team just didn't go through the methodological review part of the data science SDLC. So we started by let's just get everybody into notebooks. Let's figure out how to get everybody collaborating and show them the power of just one piece of the ecosystem. And with inline commenting and the ability to share across different functions and do it in a governed way, thanks to how we had configured Unity Catalog, we actually got a ton of buy-in really quickly. I wish I could show you some of the Slack messages, but the first couple of times we got people sharing comments and using notebooks to talk with stakeholders, it was a ton of positive feedback, and that just starts this reinforcing wheel. So we started with a quick win. The next thing we did was we tried to identify a few simple projects that we could take end to end, right? So just putting a model in a notebook isn't enough. You actually have to get it into production so it actually can make a difference to the business. So we started on the feature side. As was identified in the panel before, feature engineering is like the grossest thing ever, and a lot of times it's just copy-paste SQL. You get zero economies of scale, and it's a giant time sink. And when you get into it, you see things that should be the same but are not actually the same. You have no dependency graphs. You have no lineages. So we have started by attacking, let's get our feature store up and going, right? The bet there is get your feature store up. It's an easy process to get those data transformations into Databricks. We can schedule them with Databricks jobs. We can take advantage of CI/CD. We can start to build those. But it's a low-risk thing for the data scientists, right? Because they don't have to give up their model workflow that they're very tied into. The benefit of it is we start to populate a feature store, and then we get to ask the question of okay, how do you build a model faster? Well, you start by, let me just use all the features that already exist. I don't need to go reinvent the wheel. Start with start at 1, don't start at 0. And that's helped us accelerate our model cycle time. So where are we now? We're really in the scaling up phase. And so scaling up for us is, how do we adopt Unity Catalog to make onboarding very seamless? So if somebody starts on the casino data science team or somebody starts on the sportsbook data science team, how do they immediately log into Databricks and have access to all the resources, assets, and infrastructure that they need to do their job and be successful at their job? The second piece is ML Flow, and I highlighted this one because we've actually made a pretty strong stance, and ML Flow for us is the center of everything. And we've decided that because it gives us this nice clean interface between the research and development side of data science and then the moving into production side of data science. And we really like that. While there are other ways to do it, being pretty strict about having that as our interface, that is a core tenet of our strategy here. We're continuing to build out our feature store. The getting started and getting initially populated is the biggest piece. We're getting to the point where you kind of get diminishing marginal returns on the features, and then you have to start going through the culling, right? How do you identify what features aren't used? How do you start sunsetting them? How do you cycle new ones in? How do you come up with a promotion process? How do you come up with a refreshment process? Things like that. And then we're really getting into batch inferences. So Robin actually just stepped away, but we have at DraftKings, we have a big data science team that's dedicated to building sports betting markets. They operate in a much different world in production than we do on the consumer data science side, where batch inferences for personalization and things like that are the primary use case or the primary deployment process for us, but we're starting there. Cool. Where are we going? Really, as the goal as we keep going, the goal is to get into this well-oiled machine, right? So if you think of the greatest football, the Patriots, as a Boston person, they were literally a well-oiled machine, right? It didn't matter who was there. The process was there. They had the foundations. You could cycle anybody in, and as long as Tom Brady's your quarterback, you have a chance to win. It's kind of been a nice part to have a cheat code. But for us, it's really how do we increase the number of trials? And a trial for us is a new model. It's a new experiment. It's a new idea, right? Scientific process in data science is a non-deterministic process. And so you never know what's going to be good or bad. And so it's a probabilities game. Just like sports betting, it's a probabilities game. We want to maximize the number of shots on goal to try and maximize that. We could do that by scaling out, right? Adding more people to take shots on goal, but that's not the most efficient way. So we're doing it by trying to scale up, right? How do we get more efficiency out of our people? And then the goal there is like, let's just maximize the potential of our talent. We have people who are really good at building feature engineering pipelines and really, really enjoy that. We have people who are really good at running models in production and really enjoy that. So how do we move into that specialization side and really kind of build on that? All right, so no good coach would be, in a good spot if they didn't review the game tape and kind of give you a, feedback on your performance. So I'll tell you how it's been so far. So for us, as I reflect back on what our adoption has been over the first year, things that I think have been great, the quick win. Like if you're trying to get it new and trying to get people, like find that quick win. Don't do what somebody tells you they want you to do. Figure out what it is that you can help somebody with that makes them better immediately. And that was, for us, it built a ton of credibility with the team and drove a lot of adoption. On the flip side, no one ever talks about the bad side, but like old habits die hard. There's old habits and old processes that we're trying to break people out of. Like people are still comfortable in their own situation and you have to get them broken out of it. It takes time. It's never an overnight thing, but it helps. Then on the upside, like the way to do that is metrics matter. You just start measuring things and you have to identify what are the right things to measure. So my teams know they're in charge of two things. So one, they have to deploy an increased number of models week over week, month over month, year over year, and they have to do it faster, right? They have to cut down that cycle time. And as long as they're doing those two things, like the outcomes and the wins are gonna come, but for me, that's what I want them focused on. And if they choose to do that in Databricks, which is where we think the play is, like great. If they figure out how to do it outside of Databricks, that's also phenomenal because we're gonna learn something new as a team, but I don't think that's gonna be possible. And then, again, with any good team, you're always trying to figure out where are the opportunities to improve. So for us, like we're really starting to look at liquid clustering to solve one of the problems that we have with like trying to get simultaneous writes into the feature store. So backfilling is right now a pain point for us. And so with the release of liquid clustering to GA is like a really exciting thing for us to try. Serverless, everybody's talking about serverless. If I don't have to manage infrastructure, I can be a data scientist and just do that stuff. And then solving the model serving. So, we talked about heard about some of the personalization use cases just recently, but really getting into like, how do you do inference on demand? How do you take in a consumer's behavior in real time and make decisions based on that behavior in order to provide them the best experience? All right, cool. My last 20 seconds. So this is a very, very quick throughput of how we've decided to adopt Databricks, like the strategy we've adopted to get it embedded in our team and kind of the outcomes that we've been trying to drive with our team and where the benefits are. I think there's a lot more for us to do, but really appreciate your time, taking the time to listen.
First off, hello. Thank you for being here and sticking around. I know that we're very close to happy hours and whatever else is happening after all this, so thank you for being here. Also crazy to hear from like DraftKings and everybody, we all have the same problems, so it's kind of really cool to be able to collaborate and talk to each other and kind of learn from each other and our best practices and things. So hopefully that's what we can share with you. You're gonna hear a lot of the same kind of ideas that you've heard today, but hopefully we can expand and put a little fun little baseball flair on it. Is my ring prominent enough yet in the light? Hopefully it's glistening. Anyway, yeah, so we're going to touch on data privacy, building a foundation. We're going to talk about AI and ML, how we use that in baseball. Then, of course, we got some Gen AI stuff that we're doing in the pipeline, so I'm excited to share that. Quick introductions here, then we'll get going. Yeah, my name's Alexander Booth, Assistant Director of R&D with the Texas Rangers. Been basically our big data architect for the last couple of years, and we do our years in seasons, so this is my 7th season with the club, and I'll turn it over to my coworkers.
I'm Michael Topol. I work in baseball analytics with the Rangers. It's my 9th year in baseball, but I just joined the Rangers last year, just in time for the World Series.
Hey everyone, I'm Oliver Dykstra. I'm a data engineer for the team. This is also my 2nd season. Second season in sports as well, overall.
And we didn't win a World Series before we hired these guys, and then right afterwards we did. So nothing that I did, hell, it's just all these guys over here. Anyway, things we're going to touch on today, we're going to touch on data privacy, we're going to touch on data engineering, we're going to touch on AI and ML and KPIs, and then we're going to touch on some Gen AI stuff, and maybe we got a World Series trophy we can show at the end here. We'll see how it all comes together. For those that don't know, we're a Major League Baseball club headquartered in Arlington, Texas, which is pretty close to the Dallas-Fort Worth area. And we have a beautiful new stadium. One of our senior directors is here today, and he helped kind of do the whole thing to build this new stadium, so I got to showcase it. $1.3 billion. It's worth it though. I grew up in Texas. Oh, I'm segueing. Oh my God. I grew up in Texas. So back in the day, you'd have to go like to a game outside, 120 degrees. You're just sitting there roasting. So I love it. Air conditioned, 75 degrees. But we'll also talk about, this relates to ML, I promise, with the weather and things. But anyway, so just a quick foundation of kind of where we're at in baseball. What is data science in baseball? How are professional sports becoming data-driven enterprises? So a quick couple of slides here on the timeline. We've all probably heard of Moneyball. That was kind of the innovation or the public innovation of using data to make sports-related decisions. Billy Beane found that guys with a higher on-base percentage are more likely to score runs. They were not compensated appropriately in the market, so a little competitive advantage there. But after that, data kind of exploded. So we have ball tracking systems now, which came out in 2006. So it's tracking the spin rate, tracking the velocity, and then those only got better over the next decade. You're gonna see a product called StatCast. If you ever watched a baseball broadcast, you're gonna see brought to you by StatCast, basically after like all the big home runs and things. So it's a radar and video technology, I guess, that's not only tracking the ball, but is now tracking everything that happens on the field at a high frame rate. So a couple technology shifts there. TrackMan, who you may also hear in golf, Hawkeye, who also does tennis, and now the NBA too, so a lot of interesting things there. But with this high frame rate tracking, we're tracking the players at 30 frames per second for the entire game. We're tracking the pose. We're doing some computer vision partners that are tracking the skeletons of the pitcher and the batter at 300 frames per second. And some of the newer technologies now, we're tracking bat tracking. That was released publicly a couple of months ago, a month ago maybe. We've had it for a little bit longer, you know, being working for a club and all. But these are like really big, complicated data sources that we did not know if we were being able to transform, make leaderboards, make decisions off of. And that really was kind of the catalyst for investing in kind of the lakehouse and a cloud-based modern data architecture. So yeah, my last little slide here. Next time you go to a ballpark, look up. I promise you, you may or probably see a camera. There's at least 16 of them usually, maybe more. There's a big black box behind home plate. I promise it's even there at Oracle Stadium. So if you're going to the game tonight, at least look for one of these. So I'll pass this over to Oliver now to kind of touch on some of our data vendors.
Yeah, as we started getting these data sources and these new technologies, the providers just exploded. And so both vertically and horizontally, we've just been a total explosion of data sources. So it's not just MLB, right, the major leagues. We go down to the minors. We're collecting data at colleges now. You know, now we even have parents entering data collection in their little applications at Little League games and stuff like that. It's going everywhere. But it's also going international, you know, of course, and just tons of different sources all over the world. It's everywhere. And so, of course, the first thing that we had to do in order to address any of these issues was figure out the back end and our engineering. I first step into the cloud. I love to show this slide. Kind of just the pipeline and the lineage for one of our data products. You know, it was a big tangled mess. And the product that we were using left us really rigid. So everything was very time-based. We even had some stuff kind of scheduled on cron. So any misfires, you know, left us hanging, left our stakeholders hanging. And in the end, it was tough enough to explain how we reached the conclusions that we got to with these numbers, as well as, you know, maybe why their numbers weren't there when they wanted it.
I was also add in there, like, this is we all probably had this, right? This is like your old Oracle SQL servers, like on-prem, right? And it worked fine when, at least for our case, the only data we were getting was like box scores, like how many home runs did the Dolis Garcia hit? Maybe 1 or 2. But anyway, like I said, with the high frame rate stuff, try loading in terabytes of high frame rate, like streaming data into the SQL server. It's not gonna play well. So
yeah, it's bad news. So we were happy to jump onto a unified data platform. A lot easier to collect data from all these different sources, from you know, new biomechanics, pitch data. We're getting weather data now every 5 minutes or something at all the different stadiums. as well as scouting, medical records, player information, everything like that, and being able to use it through new data-driven, event-driven orchestration systems, through our medallion architecture, and distributing it to all of our different end users, whether it's for analysts and machine learning, off to our BI for our scouts, coaches, player development, everyone like that.
Yeah, we weren't the first to do this, and we're definitely not going to be the last, but it's worked really well for us, and we actually got this in place before kind of the World Series, so that was kind of what we think is a big win, right? Getting our data much more collaborative and much more transparent in its pipelines.
That's still me. And of course, one thing that we really love is open source software. So we're really happy with all of the different partnerships that Databricks does and explores. And these are a few of our favorites that we've been partnering up with.
Yeah, what is it? Baseball is a team sport, right? That's kind of, I think, how we try to do that slide. Anyway, we'll pivot into some data governance stuff as well here. So data governance necessarily is the most sexy thing, but at least in baseball, we actually initially we didn't do anything, and then we quickly realized that couldn't necessarily. We had to adapt and create some kind of data governance system. So again, we actually have the same types of regulations that you all probably have too. Sensitive information, medical information. Even though people really try to know how bad really is Corey Seager's groin strain. I think that's public, right? Oh God. Anyway, things about some injuries and people really want to know whether it's for fantasy purposes or whether it's just to following their favorite teams. So trying to keep that medical information, though, proprietary, stored correctly. Same thing with addresses, PII. It's kind of crazy how many people are looking for, a Corey Seager's residential address to send him fan mail and stuff. So again, trying to keep a lot of that just private and make sure that the players have their own privacy as well that they deserve. Financials is another big one. Incentives. Contract information, contract details. We don't want that to get into the wrong hands either, whether it's both internally or externally. And then, of course, we actually have the amateur draft coming up next month. And with the amateur side, again, a lot of these players are under the age of 18 or that we're scouting. And how do you kind of keep that education securely stored? How do you keep all of their personal medicals that they have to submit as well securely stored and accessed? So we actually are, FERPA and HIPAA are a couple of the regulations that we have to abide by too. And so Databricks Unity Catalog allows us to kind of manage those permissions on the cloud effectively. Another one is more about data sharing. So this is a case study that I like to pull here. I don't know if y'all heard about this. So the New York Mets, they did their first dollar hot dog night in a long time on April 30th. So I kind of love this quote. It was there's a lot of news press about their dollar hot dog night. We've been doing dollar hot dog nights at the Rangers for decades. I'm what's going on here? Anyway, in front of the $1 Wiener Boys, this sideline reporter found out that they ordered 70,000 hot dogs. And while they were super impressed they sold 44,000, that may not necessarily be great inventory management, right? So at the Rangers and throughout at the Rangers and with other kind of sporting events too, we do take that business side, that fan engagement side. I'll try to make that a little bit more AI and data driven too. So with data sharing, right, we're able to collaborate kind of with that business side and that concession side. You'll notice that if we knew things like who is starting the game tonight, or how many runs are we going to score, or is it going to thunderstorm or tornado in Texas all the time now apparently. Less people show up, less hot dogs. So maybe we could try and collaborate again and create kind of better AI-driven concessions. So yeah, using governance and shared data, we can collaborate between business, baseball, and concessions. So yeah, quick slide here about how we're doing that in multiple Databricks workspaces, utilizing everything in the Meta store with the Unity catalog. I think you've all heard that. But it's really great to kind of see that in action here, at least with our domain.
Yeah, I think we're running kind of low on time.
No,
but just to, from the perspective as an analyst, a lot of our stakeholders and customers, as you might say, are non-technical people in the front office. This shows up in the form of talent acquisition. We have the draft coming up, like they said. It could be free agent signings, trades with other teams. A lot of it these days is in player performance, player development, utilizing all of the biomechanics, the swing data, everything that we have. It's very integrated throughout the org now with the coaches. And then also in in-game strategy, we have shows up anywhere, whether it's matchups for pitchers, lineup optimizations, positioning. These are all areas that analytics touch now. And then one example, I guess, is hitting. The launch angle revolution is basically just an example of how an emphasis on analytics is represented in hitting, and emphasis on launch angle. This goes back to the data source that's almost 20 years old now of ball tracking data. We're talking about being able to build models around expected outcomes of hits given the ball tracking data. That's exit velocity, that's launch angle. Over the years, we've been able to incorporate new models that incorporate this new data, such as weather. So now we can say how much did the weather impact these balls. We can use the biomechanic data, we can use the bat tracking data, we can see, so now it's just not launch angle, it can be attack angle, it can be stride length, it can be all these different things that we're building. And as we build models, we can then give this to the coaches, we can give this to the players, to the decision makers. It shows up in lots of areas. And then this is just, another example of where it shows up on the opposite side, as we have in-game strategy for positioning. We've had the player tracking data, so we know where players are every play. We can incorporate that into our model in combination with the ball tracking. We know who the pitcher is going to be, we know who the hitter is going to be, and then we can, every team is going to have their own version of these models or algorithms. Basically, you're just trying to optimize where can we put the players in the best place to make that out. This is an aspect of the game that got so good in some ways that MLB banned it in some sense. They didn't completely ban shifting, but they put a lot of restrictions on it starting last year because it was something that it works, and it worked too well. They thought that it was, so our job is to optimize within the game, their job is to optimize the game. So we still have the models, we just have to work in the new constraints.
These charts are from this year, though, so you can still see kind of the impact that defensive shifts are having, especially with the infield on left and right-handed hitters.
Yeah, and then finally, just this is, once you talk about all these various machine learning models that we have that help us better value and evaluate the game, one thing that it does is it kind of just like strips out a lot of the randomness, gives us, and then allows us to fold them together into projections. And that's one of the main goals as an analyst, is to kind of be able to get all the information we have and generate a projection that we can give. And then we can say, hey, coaching staff, this is what's valuable. This is what actually matters for projecting future. They can work on that. Our decision makers can do that for all the various transactions we talked about. This is just a public version of it, but every team will have an internal version as well, where we're just rolling all this data, all these models, into finally into one value number, basically, of what we're trying to project, and give that for everyone.
Now, what's crazy, this is all based on machine learning. These are all machine learning-based KPIs that we're using to evaluate players, to enhance player development, to empower us to pick the correct players in the draft, all using traditional AI products. But of course, we're looking at the future. Where's everything going? What did we talk about for an hour today? Generative AI. So I got a couple slides here about how we're utilizing generative AI. If you want to see more, we have a session tomorrow where we go more in depth and not at 90 miles an hour. So could be kind of fun. Anyway, Genie, I don't know if you've seen this yet in the Databricks GA, allows kind of that natural language interface that generates SQL behind the scenes, allows for less technical stakeholders that may not knowing SQL too well to still be able to access the data easily and quickly. So in this case, we actually kind of went through, I told it what WOBA was and what I wanted to search for, and it came back and found kind of the top 10 players based off of XWOBA, which is a machine learning-based KPI that we use to evaluate hitting performance in baseball. And again, this is super useful. Like I said, we have a lot of back and forth with executives, non-technical stakeholders, coaches who say, hey, give me all the data of whatever this guy's fastballs were yesterday. And so then we have to go get it. And he's like, oh, you forgot to include this one metric that I wanted. So we go back, write another query, bring it back. So just trying to make that more efficient, democratize the data across our organization, if you will, regardless of that technical ability. And then finally, we do have a fan engagement, a Gen AI initiative that we have live during the games. Now, in the third inning, if you go look up at the scoreboard, you're going to see kind of this activation, which is very fun. Essentially, before the game or during the first inning, fans can send in photos of themselves and to whatever QR code we have floating around. And we usually have a prompt that's changing for like every game. So this one that I took, the photo cred me, by the way. So for this game, you're going to see prompt Lego minifigure. So we take kind of this photo, we run it through an image generation AI, and we get the kind of the pop out on the right here. So you're going to see that this actually worked really well. Sometimes they don't always work too well, but for this one, I was really proud of these two photos here. So other prompts we've done like Pixar, baseball player on the moon, space cowboy. I don't know. They've been going crazy with the prompts on the fan engagement side, but this always gets huge laughs from the audience whenever they see themselves up there. And so, of course, how did all of this come together? What did this all result in? I'll pass it over to you. What did it result in, Oliver?
Victory.
Victory. Yeah. Whoa. 2023 World Series champs.
And we couldn't have done it without Databricks.
So we're just getting started. Again, we have a much more in-depth talk tomorrow if you want to come out and see that for us. And hopefully we bring it back this year, right? Yeah? Go
Thanks so
team.
much, y'all.
Thanks for the time.
Cheers.
Thanks for the pleasure.